Hi everyone and welcome back to the Python Daredevil Machine Learning Library series. And in this video discussing about the Seaborn library in Python. So पिछले वीडियो में हम लोग मैटप्लॉटलिब के बारे में जाना था. So which one also one data visualization library in Python. And Seaborn is also the data visualization library which one much better than matplotlib, and also Seaborn working on the top of the matplotlib. And this video is a combination of the Hindi and English, but most of the time I am trying to use the English word. So बिना किसी देर के हर हर महादेव बोल के start करते tutorial. So first what you need to do, you need to simply installing this library on our system. So for that you can also use your Jupyter notebook or you can also use your terminal. So you need to give here type here a command that's called the pip install Seaborn. So let's say I'm going to type pip install Seaborn and shift enter, or you can also using here the run button on your Jupyter notebook, right? So maybe sometime it's not working in your case because by default when actually installing this Jupyter notebook actually set the pip also, so that's why it's working in my case, and I can use this shell as a terminal also, right? So in your case you need to give here the exclamatory sign when you are using the Google Colab or any notebook. You need to give here the exclamatory sign, right? So you need to memorize this thing. Okay, then what I can do, we can simply going to import it here. यहाँ पर हम लोग को import भी करना पड़ेगा इसको. So let's say I'm going to import it. So let's say I'm going to import here the Seaborn as SNS. So this SNS is nothing but the LIS, and using this one you can also access this SNS library, right? So now what I can do, we can simply shift enter to running this shell. Then we're going to loading one data set which one already available inside our SNS library. Then we do some analysis on that, like univariate analysis, the bivariate analysis, and so on, right? Like we're going to plotting some distribution plot. We're going to exploring all the things inside the SNS library. So which one much better than matplotlib? Also one more thing, when you install the Seaborn, make sure you also install the matplotlib library. Otherwise it's not work. Because Seaborn is working on the top of the matplotlib, right? Okay, fine. Then what I can do, we can simply load it the data set sns.load data set, and we're going to pass here the data set name. So let's say I'm going to use here the tips, the data set name. If I'm trying to store it inside the df, and you can see like that. So let's say df dot head. Then you can see here this is nothing but one data frame. This is nothing but one data frame. If I try to check its type of the data df, and this is nothing but one pandas data frame, which are already available inside our SNS library. Well, now you can see here we load our data set, it having some column, total bill, tip, sex, and the smoker, day, time, and the size. Now based on that, what I can do, we can do some analysis on that. So first analysis is called the correlation between the matrices. So this is nothing but the part of the feature engineering, also called the feature extraction part. So in next few tutorial, when I do some projects, we actually basically cover three projects on this topic. When this tutorial actually end. So this is the last tutorial on the data visualization for the Daredevil Python machine learning library. Then you're going to do three projects. Then you can actually understand what actually happening inside here, and you can export it well, right? Then what I can do, we can simply checking for the correlations. So correlation actually help us to getting the idea behind your numerical column. See, this is the numerical column. Numerical means the continuous value, and the categorical means it's the string type of value. So here the sex and the smoker and the day and the time are the categorical value. So you need to also handle it out, right? We actually handle it in the later on, right? How you do the EDA part, the exploratory data analysis part, right? So you can see here this is the numerical part. So that's why it's showing up total bill, the tip, and the size. Which one is numerical? Now you can see this is nothing but one simple matrix. We can also visualize this matrix in a heat map. So that I need to use here the SNS dot heat map like that, and you're going to pass here my df dot correlations like that. Then you can see here my correlation matrix is showing up. With having some, you can see here the some color actually showing up, and based on that you can check the correlation matrix of your data. This is how you can check the correlation. If it is a highly correlated, then you can actually neglect the column, right? You don't need to put it, right? So this is the part of the feature engineering, or you can say the feature selection. Now we're going to checking for the join plot. So join plot is basically using for the univariate analysis. So univariate means just analyzing the one thing. Let's say you have some features. So let's take some shell. So let's say I have the feature number 1, and I have the feature number 2, and I have the feature number 3. Then I have one target column. So now based on the feature column, I can predict the target column, right? So this is nothing but called the supervised machine learning. That's called the supervised machine learning. Supervised. That's mean it is working based on the supervision. It having the feature and having the target. Now what is nothing but the univariate analysis? That's called the univariate analysis like that, right? So univariate means just single column. You can analyze the single column with the target column, and the bivariate means that's having two column, right? Two column and the one target column. If it is the third, I mean 3D, then it having the three feature columns and one target column. So now univariate analysis is nothing but for checking for the one column, right? Okay. Then what I can do, it's better you can make it mark down like that. Okay, so F1 F3 the target, the supervised machine learning, and univariate analysis. Okay, fine. Then what I can do, you can using here the joint plot. So in order to joint plot, using the joint plot, we can checking the analysis between the feature column and the target column. So in the feature, that's having just one single column, and you need to put here the target column. So if I go up, so you can see here, based on the tip value, I am going to predict the total bill, right? I need to predict the total bill here. Total bill, I need to predict it, right? This is nothing but my target column. So in the x-axis, I need to give here my columns, I mean the numerical column, and in the y-axis, I need to give the target column. So let's give it out. So then what I can do, in the x column, I need to give here my tip. So tip is for the nothing, but for the univariate analysis, that's having just one single feature. यहाँ पर हमको जस्ट सिंगल फीचर देना पड़ेगा यूनिवेरिएट में. सो बाइवेरिएट होगा तो आप वहां पर टू फीचर भी दे सकते हो, राइट? सो देन व्हाट आई कैन डू फॉर द वाई, वी कैन गिविंग हियर द टारगेट क्लास. हमको टारगेट क्लास यहाँ पर देना पड़ेगा. सो हमारा टारगेट क्या है? हमारा टारगेट है टोटल बिल. इसको कॉपी करना यहाँ से एंड यहाँ पर जाके पेस्ट कर देना. हो गया ना? एंड व्हाट आई कैन डू, इन टू गिव माय डेटा. यहाँ पर हमारा डेटा भी देना पड़ेगा. डेटा दे दिया. लेट्स से काइंड. सो काइंड मीन्स व्हाट काइंड ऑफ प्लॉट दैट यू नीड. So there are so many plots are available. Let's say choosing the hexagonal choose करते. हो गया. Seaborn has no attribute joint plot. Okay, it should be joint plot. Joint. Okay, then you can see joint plot. See, this is nothing but the distribution of your data in histogram way. And in the x-axis, this is not the y-axis. The x-axis, in the x-axis you can see the tip. And in the y-axis you can see the total number bill. Now based on that, in this region, the 20 to 10, it having some more value are available. You can also create one line for that. That's mean in the most of the value are available inside this 20 to 10 of the two. This is the higher and this is the higher. I mean this portion. Now you can see it's quite black. This is how you can do the univariate analysis, right? So you can also draw some regression line also. So let's say I'm going to copy this out and let's paste it. You can also check for the regression line. Let's say make it red. Then you can see the regression line. You can see this one, I think about my distributions, normal distribution, and you can see the best fit line. And you can see in the 20 to 10, it having some value. You can see in 20 to 10, it having some more amount of value. And this is talking about the outlier, right? You can the outlier. You can also predict it. You can also check this out, that how can you do the box plot using the SNS. And you already show this out, that how can you plot the box plot using the matplotlib. And you can see rather than a matplotlib, the plot looks like grid, right? Quite great. Now you're going to checking for the pair plot. So let's say SNS dot pair plot. So pair plot is nothing but for the bivariate analysis. That's when it having the multiple number of feature. So let's say I'm checking for the DF. Then you can see the features column with having the total number bill, the tip, and the size. So this pair plot actually working on the numerical data, right? See, it having the 6 column, but it actually working on the total number bill, the tip, and the size, because those are the numerical column, right? And you can see the distribution of that. It is a distribution, right? And distribution and how many value are available, and based on that you can actually do some analysis on that, and you can apply the machine learning algorithm. So now let's say I'm trying to apply the float based on this uh, tip column, based on the tip column. Okay, based on the sex column, that male or the female column. It's better, right? So let's say what I can do, I am simply going to uh, do it. Let's say SNS dot fear plot, that how many value are available inside the sex column based on the sex column. So I can give here the hue, and let's say I'm going to give here and shift enter, right? Then what I can do, you can see based on the sex column, I mean male and the female, we can checking the value, the distribution of the data, that how many are value are distributed, right? And you can see the distributions of the data. You can also check this, you can also change it out. Let's say I'm going to change it with the help of the day. Let's say day. Where is it? Yeah, here is it. Let's say day, and you can see based on the day, it is showing the distribution plot, right? And you can see it have a Thursday, Friday, Saturday, and Sunday, and based on that, you can see here three density, right? So this is how you actually do the analysis on your data set, right? Then what I can do, we can also checking for the dist plot. So dist plot actually help us to checking the distribution, if your data is distributed incorrectly or not, is it normal distribution or the Gaussian distribution. Then you can do some analysis and do some feature engineering on that, and you can simply analyze using a dist plot. So what I can do, you can simply using here the SNS dot dist plot. Then I'm going to pass here the single column. So what I can do, I can give here my tip, just tip, and you can see the distribution of the tip column. So this is the distribution of our data set for the based on the tip. You can also give it as the based on the size. So let's check this out. Size is not matter, but tip is matter. For total bill, so total bill is nothing but my, okay, it's not total bill, it's nothing but my target column. So I don't need to checking for the distributions, right? Okay, so let's say make it tips, tip. Okay, fine. So this is the distribution of the tip data set, and you can see here y level is the density and x level is nothing but the tip, right? So distribution plot actually help us to distribution of the column feature. Okay, well, you can also make this tip should be changed. I mean, you can also give it some beans, the difference between them. So then what I can do, you can also copy this out, this plot. Okay, just show that how the code actually works. Then when you do the projects in the EDA and the feature engineering part, then we're actually discussing about this thing very well. Don't worry on that. So then what I can do, you can also give here some property. Let's it having some beans. Let's say beans give, let's say 10, and you can see the based on the beans, it can show the things, and you can see here this is the beans. You don't have the beans by default, maybe 10. So let's say make it 20, and you can see here based on the beans, and you can see the distribution of changes, right? And you can see how it's look like, right? You can also make this caddy should be false, so caddy should be false, and you can see, okay, you don't have the distribution. So with the distribution, you can also checking that how the distribution look like. You can make it 10, so you can see this look better now. So this is nothing but a distribution of my data set, right? So this is how you can actually handling the numerical column. Now we're going to checking for the categorical column, that it having some categorical column like sex, the smoker, and the day and the time. So this is nothing but a categorical column. Now my question is, how are you using the heat map or the joint plot or the dist plot or the pair plot? It's not showing up. It's not showing up. So then what I can do, we can simply using here some property in the Seaborn like box plot, the violin plot, the count plot, and the bar plot. Using this, you can check the distribution of our categorical column. So let's say checking for the categorical column. Let's say categorical column. Okay. This is my category column. Let's make it markdown, and okay, done. Okay, now what I can do, we can simply do the count plot of the sex. So let's say SNS dot count plot. It is nothing but checking for the data is a balance of the imbalance. Using this, you can actually checking for that. So you need to give here your column. So let's say give here the column, and I'm going to give here my data. So my data is nothing but my DF, and based on that, you can check that how many value are for the male, how many value are for the female. You can also checking for the day or days, day, the Thursday, the Friday, the Saturday. There's so many less number of the Friday. Based on that, you can actually checking the count number of count I mean, how many value are available. You can actually do this out. You can also make it out in the y-axis too. I can copy this out. So let's copy and let's make it y. Then you can see this thing in the y-axis too. As you can see, let's make it sex now. There you can see. So based on that y-axis and the axis, you can actually doing the counting plot. So this is how you actually counting plot, and you can also checking for the bar plot. You can also do the bar plot. So let's say I'm trying to plotting based on the target column, based on my target column. So my target column is nothing but the total bill, right? Total bill. So what I can do, I can simply give here my x-axis and the y-axis. So let's say I'm going to taking the value, let's say SNS dot bar plot. So we're going to checking with the based of my bar plot. I mean, how many value are available if the data is a balance or not. You can checking this like way. So let's say on the x-axis, I'm going to give here my total number of bill. Then what I can do, I can simply go here the y, and let's say give here the sex column, and let to give here the data as nothing but ydf. Now based on that, you can see here the how many male value and the how many female value are available. If I trying to remove the x-axis, and let's check this out, it is give me the some error. I mean, based on the orientations, you can actually checking on the target column or any column you can do. Let's say I'm trying to make it there. So you can see here, neither x or y variable appear to be numeric. There should be some numerical column. I mean, it having just one numerical column and having some categorical column. So if I trying to make it tips, so this is nothing but my categorical column, and now based on the tips, it having some value, right? You can see the bar plot. So let's make it total bit now, okay? Because you have to upload it in the GitHub, so that's why. Okay, so that's mean bar plot. You need to give here one categorical column and also one numerical column, and based on that, you can actually plotting them. You can plotting them, and this is nothing but for the count plot. You can actually give here the one single column in the x-axis and also the y-axis. Now what I can do, you can also make it, you can see this is nothing but in the vertical order. You can make it y, and you can also make it x. So then it actually look like the straight one. And you can see here, right? Okay, let's copy this out and also paste it here so that you can use it as a reference. Okay, so is a x, and if you're trying to make it y, so it will show up the vertical order. This is how you can check checking for the bar plot. Okay, so now what I can do, we're going to import, we are going to actually export another plot that's called the box plot. So this box plot is actually help us to do the data representations, that if there are any outlier or not. You can also checking these things like that you actually already seen earlier in the matplotlib. So it's also available inside the Seaborn. So what I can do, we're going to using the Seaborn sns.boxplot, boxplot, and I'm going to keep here some column. So I need to give here one category column and also one numerical column. So let's say I'm trying to give here my total bill. So total bill in a y-axis. Okay, total bill in a y-axis. And in the x-axis, what I can do, I'm going to give here my one category column. Let's say which one I can give. Let's say the smoker column. Let's say I'm going to give it out, smoker column. Okay, in the x-axis, I'm going to give here the smoker column. Smoker column देते हैं, इसके बाद y पे देते हैं टोटल नंबर ऑफ बिल, इसके बाद हमको पास करना पड़ेगा डेटा, पास कर दिया. अब देखो बॉक्स प्लॉट. सो स्मोकर कॉलम पे कुछ आउटलेयर वगैरह है, देखो यहाँ पर कुछ आउटलेयर वगैरह है, वो भी हमको रिमूव करना पड़ेगा. हाउ यू डू द फीचर इंजीनियरिंग, राइट? सो लेट्स चेक फॉर द डे. सो डे पे भी है कुछ आउटलेयर वगैरह. सो सेक्स पे क्या है, क्या शायद नहीं है होगा. हाँ, यहाँ पर भी कुछ आउटलेयर वगैरह है टोटल बिल के, राइट? So based on the total bill, it having some outlier on the each every column, right? Which one is not necessary while you are building the machine learning model. Then you can actually remove the outlier of the data. Then you can create here one generalized machine learning model, right? So you can also do some changes on your data, I mean on your plot, and you can see here this is just having the single color. Let's make it day. So it having the 4-1, right? So if Thursday, Friday, Saturday and Sunday, you can also do some changes on the palette. Also you can give here some color. So let's say palette, and I'm going to give here, let's say rainbow. Yeah, now you can see some different color. So using that, you can actually checking for the outlier, that data, how the data is going to look like. You can also check the orientation of the data. So let's say I'm going to give you the orientation. Orient equal to, let's say, give it the B orient. Then you can see here, this is the orientation for the B. And if I try to copy this and I'm going to paste it for the another shell, I'd pass it here. And if I remove the orient, then you can see the difference between them. Rainbow, इसको यहाँ से remove करना पड़ेगा. हो गया. Then you can see the orientation of the data. It's quite different, quite okay, right? No different here. So this is how actually you can actually see the distribution of your data set, right? So now let's see the Boolean plot also. So it's also same as it is for the kernel density, estimation of the kernel density. They also call the KDE, right? Kernel density functions. So you can using this Boolean plot also, SNS dot bio. Let's say you can press the tab, so it will showing, give you the auto suggestions. Then in the X, let's say give you the total number of bill. So see one thing, when you are working on a categorical column, and you need to also give here the numerical column also in the x-axis or the y-axis. Make sure that you actually remember this one, right? Yeah, you aapko remember karna padega. Then what I can do, I can pass here my categorical column in the y-axis. Then let's say I need to give here my data. So let's say data equal to df, and shift enter. Then you can see the Boolean plot with having the density, I mean kernel density, the distribution of the data, and also the outlier. And you can see it's not quite good. I mean the इतना अच्छा भी नहीं है क्योंकि figure इतना छोटा है इसलिए, right? So they equal to df, and you can also give the palette. Let's copy this out. You can change the palette. So it's also same as it is for the box plot too. It's just having the distributions of data, and you also see these things again already in our density. You can see the KD, the kernel density functions. So let's check this out, right? So that's it for today now. Hope you enjoyed this tutorial. And it's better you can also checking with another one, that for the iris. You can also check for the iris one. So this is also one data for iris flower recognition. I mean this data set, it having a sepal length, sepal width, petal length, the petal width, and species. You know, to also predicting the species column, right? So it also it having just having all the numerical columns. That's why choosing the tips one. So that's why choosing the tips one, because it having some numerical column and also the category column. That's why I decided to taking this data set to making this tutorial, right? So that's it for today now. Hope you enjoyed this tutorial, and make sure to subscribe to channels, and don't forget to hit the bell icon. And the next tutorial we are going to be discussing about some projects based on the EDA and the feature engineering, right? So that's it for today now.